Hello and how is everyone? Today we are back doing another question, the problem of the day for 22nd May. And today is the question number 33. Very famous question. Sometimes LeetCode does give old questions as problem of the day also. So today our question is search in rotated sorted array, and it is a medium level question. It is a very famous question to be honest, but if you don't know it, then this video could be a great learning lesson for you. So let's begin with the question. There is an integer array nums sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly left rotated at an unknown index k, such that the resulting is nums k plus 1 up to nums 1. Okay, so initially our array was sorted, but then any particular index was chosen, and then along that index it was left rotated. So here it was rotated by left rotated by three indices, and this is what we get as the new array. And two things to note is that in our question we have been told that initially it was is in ascending order, and all the elements are distinct. There is no duplicate values in the array. Okay, so given the array nums after the possible rotation and an integer target, return the index of the target if it is in nums or -1 if it is not in nums. Okay, so if here since it is an ascending array and it is rotated along an array of with ascending order, I get an idea that binary search will be applied here because I have to search in that array. And let's see the time complex constraint. Our constraint is the length is less than 5000. So even if I do a big of n solution doing linear search, that will also work. But here we will try to do our most optimal solution. A brute force solution would obviously be going through the array, traversing through the array and checking each element. But here we will be doing the most optimal solution, and that is through binary search. So let's understand the question more deeply, how binary search will be applied here, and move to the whiteboard. Okay, so this is how our question looks like. Suppose this is our array, the sorted array that was initially given, and then this array is left rotated by k places. Let me just left rotate it here, and yeah, let me paste it here. So this is our new array now, and suppose it is left rotated by three places. So I just select these three, and it is left rotated. So this is how our new array becomes. And if you see a pattern here, like if you see the last element here, that is 5, and it is the highest element in this side, and if you see the lowest element at this side, that is 6, the lowest element of this side is greater than highest element of this side, which implies that every element in this section will be greater than every element in this section, because the highest element here is smaller than the smallest element here. You can understand it visually by this. That's why I have drawn it like this. So yeah, you can see clearly that every element here will be smaller than this element, this side. So I get the impression that I will use a binary search here because it is still in somewhat and sorted order here. So suppose this is my low and this is my high. Now from here I can have two main cases, and inside each case I have two cases. So first of all, let's move to our first case. Suppose our mid is somewhere here. Yeah, suppose our mid is here. Just suppose like in some iteration we get our mid to be here. In that case, if you like, yeah, first of all we will check if our mid is double equal to target. If our mid is double equal to our target element, then we will simply output that index as our result. If it is not equal to our target element, then I will check if the nums of low is less than equal to nums of mid, because if it is less than equal to nums of mid, then I am sure that I am in this sorted section. So after that I will see where is my target located. If my target is between low and nums, if my target is greater than low and less than mid, I know for sure that it is somewhere in this section. So I will then move on with a binary search in this section and find my target element. Otherwise, if my target is not between nums low and nums mid, if it is suppose less than nums low, so then it has to be somewhere in this section. And if it is somewhere in this section, then I need to shrink my window to go this side. So I will move my low to be mid plus 1, and then I will check this section. In second case, what could have happened was, suppose if our mid was somewhere here, and in that case our nums of low was greater than nums of mid. So then we would have checked for the location of our target. If our target was greater than nums of low, but it was greater than nums of mid, then we knew that it has to be behind nums of mid, because all the elements ahead of mid are greater than low. So it has to be somewhere here. So I just move my high to be mid minus 1. And similarly, if target was somewhere here, and I see that my target was less than nums of mid, nums of low, but it was greater than nums of mid, I know it has to be somewhere in this section, because all the elements that will be in this beyond mid, before mid, they will be greater than low, and I need an element which is less than low. So then I will do binary search in this section, and then I will move my low to mid plus 1, and then we will check in this section. So I hope the rough idea is clear here, and let's start coding then. Okay, so we are here, and yeah, let's begin. First of all, we assign our low to be equal to 0, and our high will be somewhere like at the end of the nums array. Then I will run a binary search loop while low is less than equal to high. I need a condition so that at some point we can break out of the loop. First of all, I will compute mid, and to compute mid here, I will do low plus high minus low by 2. I can also do high plus low by 2, and since the constants are here such that there won't be any issue, but generally this is a good practice to write like this, because when you will be doing bit better questions, there might be questions where integer overflow might happen here. So this ensures that in the given constants your integer overflow don't happen. So yeah, now I check if my nums mid is double equal to target. If I'm already at target element, I don't need to check anywhere further, I just return mid. But if it is not like if nums mid is double equal to target, it just returns mid and my code ends there. But if it is not, then I go for the further conditions. First of all, I check how is nums of low in respect to nums of mid. So if I say that nums of low is less than equal to nums of mid, then I'm pretty sure that I'm in this section. Here somewhere is our mid, here somewhere is our low. So now I check for where is our target element. So if target element is greater than equal to like nums of low, and if it is less than nums of high, sorry, nums of mid, so it has to be somewhere in between. So I just go to my here, I then I will have to shrink my array to this side, because our target is somewhere here, our mid is here, our low is here. So we will have to shrink the array. So high has to go somewhere here, high has to be shrinked. So high has to be shrinked. So I go here and then I shrink the mid. Height will be equal to mid minus 1. Otherwise, if that's not the case, if target is somewhere in that part, then I will have to shrink the other way around. If the target was somewhere here and high was here, so I would have to shrink low to this side then. So then my low will be equal to mid plus 1. So yeah. Now let's check for the second condition, when nums of low was greater than nums of mid. So this is our second condition, nums of low was greater than nums of mid. Now again we will check for target. Where is target? If here target is greater than nums of mid, and if it is less than nums of high, then I'm pretty sure that it has to be somewhere here. It has to be somewhere here. Then low needs to be shrink to that side. So then I will do low is equal to mid plus 1. And otherwise, if that's not the case, then I will have to shrink my high to the other side. If my target was somewhere here and my low was here, so I know for sure that if my target is here, then high needs to be shifted this side or to the left side. So high comes somewhere here. So then my high becomes mid minus 1. And if I then if we run this loop over and over again, suppose that element was not present in the array, and at some point our high crosses our low, so we know for sure then the element doesn't exist in that array, and then we will simply return minus 1. this is how our code is, and I think this will run. Let's check if we are getting right results. Okay, there's a compiler error. Are we doing any error? Just let me check. Okay, we are returning inside the while loop. That is a issue. Just put it here, and yeah, this should run well now. Yeah, and I just enter it to check if it's getting accepted. Yeah, let's go. Our code is accepted, and it is beating 100% of solutions. So this is the most optimal solution out there. I hope you got to learn something from this video, and if there were any doubts or any suggestions, feel free to comment. Thank you for watching. Signing off.